Alright, let's go, let's go. Alright, I feel pretty good about this today, even though it's a hard. Let's see what it is. Maximize the minimum powered city. You're given a zero index integer array stations of length n, where stations at I represents the number of power stations in the ith city. The number of power stations. So I represents the city index. And, okay. Each power station can provide power to every city in a fixed range. In other words, if the range is denoted by R, then a power station at city I can provide power to all cities J such that, okay, so basically stations I is just kind of a distance, how far away from that position, the ith position you can power. At the absolute value of x, okay, yeah. The power of a city is the total number of power station. Power of a city is the total number of power station is being provided power from, okay. A government has sanctioned building K. A government has sanctioned building K more power stations, each of which can be built in any city and has the same range as the pre-existing ones. Government has sanctioned building K more power stations. Okay, so the government is going to build K more power stations, each of which can be built in any city and have the same range as the pre-existing ones. Okay, so you can add to the power stations of any city. Given two integers r and k, return the maximum possible minimum power of a city. Okay, so you want to have the lowest, highest min possible if the additional power station are built ultimately. Note that you can build k power stations in multiple cities. Yeah, okay, so k is kind of like little chips that you can add to any city. So there, here you can add two power stations. R is the range of okay, so each power station can provide power to R range. So 1, 2, 4, 5, 0. So I guess this means that the 5 can give 5 power to this and 5 power to this. So right now it's like maybe, I'm gonna guess this can be 3, 6, no 7. Would be 3, 7, 4 plus 7, 3, 7, 11, 9, 5 currently. And so you probably want to increase this thing by 2, so you probably want to give 2 here. And so the minimum would be 5. Yeah, install both power stations at index 1. So you can 1, 4, 4, 5, 0. Yeah, okay, I see, yep. 5, 9, yep. R 0, so distribute 1 to each of these, but then the other one still has 4, so this can only be 4. Okay, in general, first ideas would be whenever you do a maximum possible minimum power, it's quite possible to use or often this could be a binary search where you guess what the minimum power would be and see if it's possible. If it's possible, then you try to guess higher. If it's not possible, then you guess lower. And then at some point you have the guess that is right in the middle where it's not possible to be higher, or it's not possible to be lower, or whatever, however you want to consider it. Is that what I want to do? Or is there a linear approach to it, because binary search is going to be n log n. Linear approach to this. Maybe there's a linear approach. So linear approach would be what? Keep track of I guess you can initially see, yeah, okay, you can initially see what the power level is for each city without building any more stations. And then the difficult part is like allocating it, right? Like you can allocate for the allocate the stations to the lowest cities, but you don't know where it is, and then whether it should be on the city or to the left or right of the city, and then like that uncertainty chains off. So I think this is probably going to be a binary search. So first attempt would be binary search method, which is to say guess the min power level. See if it works. If it works, then guess higher. If it doesn't work, guess lower until you're until the guess is at the boundary between possible and impossible, and that'll give you your highest possible. Okay, so in general, this means that you need a single function that is generally returning true or false is possible, and it'll be some power level, I'll say p level, and this needs to be linear. So if I were to say, if my stations, is it possible to get all the stations to have at least four level, and then how to allocate that. If you were to do that, then you would want to, if the city is at a deficit from the level, you would allocate the station farthest away to the kind of right unexplored area, and that should maximize the station, maximize the ability for that station to be effective. Okay, so I think so unallocated is going to be initially k stations, and allocated. Okay, so I'll say I think I need a new stations maybe. New stations is going to be 0 times the length, and it's the length of the number of stations. So I think this times n. So this is, so if I have k equals 2, that means like I'm trying to figure out where I'm putting those 2 into a new slot. And then I'll add the 2 arrays at certain indices to get the total number of stations at a particular index. So how to do that efficiently? Eeks. So for instance, if I say power level needs to be 4, let's say I have 20 new stations with range 1, so I would probably want to do like 20, that's 1 away from this current station. So I want my min level to be 4, so I need to have 3 more here. Let's allocate 3 at index 1. And allocate 3 at index 1. Okay. Yeah, somehow keep a kind of a sliding window of in-range power stations from the current index that will naturally kind of determine the power level at the current station, at the current index. And then it's almost like it'd be a queue, a deck. So that could be a deck. I could just use a sliding window and then have to have a deck. Yeah, I could have indices. Okay. Let's say I need to do my initial setup. I want to say I want to append some zeros to the stations. Like append a bunch of dummy zeros at the end. Is it extend? 0 times, say it's r minus 1. So that it almost wraps around with zeros. That doesn't print out anything, huh? Oh, well, that's r was equal to 1, so let's actually put 0 times r. Is it r or r minus 1? Yes, r. I want to have another 0 there. Okay. And then the other one, this wouldn't extend at all. Okay. And then the initial setup is, this needs to be correct. New stations will be n plus r. Just to not go out of bounds. Okay. Maybe I don't even need the new stations, to be honest. I could probably modify stations. No, I don't want to modify stations. I don't want to have to recopy it each time. Yeah, I guess new stations is fine. Okay. new stations. So let's set up the current range, the total. So let's say the current level is equal to, what's it going to equal here? So I have r equals 1. R equals 1, then it should cover these two. I want the current total to not include the last one of the range. So it'd be r minus 1. R minus 1. So it would be something like for index in range r minus 1. Let's say cur is 0, and then current plus equals stations at index. I think that's right. Okay. Okay, that's the initial setup. That's kind of, yeah, that's the initial setup. Okay, station or index in range from r minus 1 to n. So this is the sliding window part where I can safely always assume that whatever I'm doing is going to completely analyze the current index. Okay, so the right side, I guess I can call this right. The right side of the window is going to be r minus 1. So if r is 1, it must be 0. I think it should be r, no? Minus 1. Actually, it might be r here. If r is equal to 1, it should be going to the first station. Index 0. Yeah, okay. The value on the right value is going to be stations at right index, and then how much I need would be, well, I can check if possible. So if there is need, that means that the current, actually I need to actually add this in, right? Current plus equals the right value. If that current is less than the needed power level that I'm going to check for, then the deficit needs to be made up from the unallocated. Okay, if P level, power level minus the current is greater than the unallocated, then it's not possible. This is, by the way, returns true if there is an allocation whereby all cities can reach the P level, power level, P level. else unallocated is going to subtract the difference. Unallocated is going to subtract the difference between the minimum and the current, and the new stations should be added here. New stations at the right index. Okay, so let's call this deficit is the P level minus the current. The unallocated subtracts the deficit. And the new stations at the right side is equal to the deficit. I think that's correct. Okay. And then it does it. And now this is going to close the window on the left. So now it needs to remove the leftmost side of the window. So this is going to be left value is equal to stations at, where's this going to be? It's going to be like right minus 2k or right minus 2r, something like that. So let's say the right index is at 2 currently, 0, 1, 2. So it adds it to the window. The window is like 1, 2, 4. And then it does check. And then it should remove the 1 from the window, so it becomes 2, 4, and then the next time it does it, this becomes 2, 4, 5. So that does seem like it would be right index minus 2r. Right minus 2 times r. And this doesn't go out of bounds because of the dummy zeros at the end of the array for initial starting index. And it needs to do this for both the stations and the new stations, which added power to this current window. I think that's actually pretty good. Then after all that, it returns true because it didn't return false during the loop. Okay. And then it's just using binary search. So what's the what's the minimum and what's the maximum? What's the minimum? What's the maximum? I guess I can set the minimum to be at least the minimum of the array. So low is the minimum stations. And then the high should probably be, what could the theoretically high be? High could be the highest of the array plus stations length divided by k divided by stations length, something like that. K divided by station length. I think that's right. K divided by station length. Right. No, that's not right. That's not right. That's assuming that each station gets dropped onto the city, but then they have range to it, so maybe just somehow each station affects everything. Each additional station affects every city. Something like that. Okay, and then the binary loop will be while low is less than high. This is always kind of tricky for me. The mid is going to be low plus high divided by 2. Check if it's possible. And if it is, then if it's possible, then guess higher. So that would mean that you would bump up the low. Low equals mid plus 1 or mid? Low equals mid plus 1, I think, because low and high could be like 0 and 1 or like 1 and 2. So the mid is at 1 and you check 2. Else you need to guess something lower. So I think high is equal to mid. And then I think you return, so that's going to stop when it's false. It's going to stop when it's false. Stop when it's too high, so I think it needs to return mid. Guess is 2. Let's say low is 2, high is 3. 2 is possible, 3 is not. Mid is 2. So it does a loop. Low becomes 3. So I think it should return high minus 1. It goes too high, something like that. You could also do low minus 1. Oh boy, okay. So it does this one incorrectly. Okay. Interesting. The output was 6. Whoa, Nilly, that's a lot. How did we get to 6, really? The current level is less than unallocated. If the deficit is, okay, let's go ahead and just fix this thing here. The deficit is the difference. If the deficit is greater than how many things you have left to allocate, then return false. Otherwise, your unallocated should be reduced by how much you spend. The new station's at the right side, it becomes whatever you need to put there. Really? Okay, let's trace through it here. Print low, high, term value. So at first guess that the min could be 4, the high could be 7. Oh boy. So it's possible to do 4, 7. That shouldn't be possible. The mid is 5 at that point. Oh, that should not be possible. Mid, it shouldn't be possible to do 5. Okay, so how did it get 5 here? Unallocated is 3. The zeros everywhere. The current is going to be hopefully it's going to be 4. No, hopefully 0 actually. 0. Okay. So 0 adds 4. So adds 4, index 0. So current's 4. 4 is less than 5. So def should be 1. And let's go. Yeah. So it should be assigning like 1, 1, 1, really. Yeah, so assigns 1. Oh shit. Deficit somehow became 2. Ooh boy. Well, actually, looks like it only got the deficit once. Did I not subtract current? Fuck me. The left value. Oh my god, I'm so stupid. The current is subtracting the left value, which is stations at right minus 2r and new stations at right minus 2r. Oh, okay. And I think that should be it. Do 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 do. Oh shucks, zeros. Ah, the trivial case or the weird edge case. Interesting. There's 1 station, 1 power. My output is 0, but it picks 1. Huh. Alright, sure, let's go ahead and test this. Let's see what it is up to. The min and the max should be 1 and 1. Oh, I see. Yeah, the min and max is 1 and 1. So therefore, low is equal to, yeah, so they're equal to 1, and I return 0. Interesting. How to fix this? Guess I could do like high is equal to max stations plus k plus 1. That should that should be it. It has to be impossible. So literally impossible. Because it has this thing assumes that you're going to reach some impossible value for high and then return one less than it. So in theory, it actually could be possible to have max stations plus k as the answer that it returns. So therefore, it should not be used as the initial high. Oh my god. 4, 2, 1. So what did I return here? I returned 5. It should be 7. What? Really? Oh my god. Yeah, okay, that's a pretty bad logic error. Like, I did not consider stations affecting each other. Okay, that's just stupid of me. I guess the high is actually the sum of all stations, assuming every station affects every other station, plus k plus 1, I think. Yeah. The sum of all stations plus k plus 1. Well, that's not even it. Is it? 6 plus 1. Yeah, 8. Yeah. Oh, build more errors. Wow, this is really bad. Like, I'm not even getting to that many test cases. So here I'm doing 6. This should have been 9. Literally, if I just did infinite here, this would have worked here, I think. Here k can affect every. Actually, what's wrong with this one? Sum of all stations. K is 14. How could it possibly? This one, I'm actually not sure. Okay. Alright, buddy, what are you doing? 2, 10, 12, 3. So the correct answer was 9, was it? Expected is 9. 212, 222, 42. So mid says testing 40 is testing to see if 22 works. It doesn't. Test 12 to see if it works. It doesn't. Test 7 to see if it works in it. It should actually work. Expected is 9. So somehow it doesn't see that 9 is possible, or 7 is possible even. Why wouldn't it see that 7 is possible? So R is 0. So 2 would need to have 7 added to it. No, 2 would need to have 5 added to get to 7. And then this would be fine, this would be fine, and then 3 would need another 4. That should be within 14. Huh, okay. I guess I need to see this more. I guess I can put it right here. Print the right index, the deficit, and the current allocated, unallocated, and the deficit before the false return. So 2, 7, So it's at index 3, 0, 1, 2, 3, so it's at the spot. The deficit's 5. Deficit's no, unallocated is 5. Whoa, why is it 5? That's a really low unallocated amount. Allocated should be 10 at the point. No, allocated 5 to get 2 to 7, so allocated should be 9. Unallocated should be 9. And the deficit's 13, you say? Really? Huh. Okay, I guess I need to see more information. It's probably too much information. Print it out. Sure. So 0, 2, index 0, current is 2. 1, 5, what the hell's going on there? Current should be 10. Oh boy, oh boy. Oh, I see. I didn't actually add the current. I don't think I actually added. Oh, this is pretty bad. I never added the new power stations into the current window of power. Oh my god, how did it even pass anything if that was a mistake? Doo-doo-doo-doo. Wow, I was so confident. I guess I was hoping that the test cases would actually catch that mistake. Or a mistake of that magnitude. Oh, more stuff. Okay, so 52 is expected, 56 was my return. Oh, add this test case. 56. Okay. 0, 39, 78. So again, the right answer was 52. 52. So I tried 59, didn't work. 49 worked, 54 works. Whereas it should have not worked. This 52 should have been high. Okay. Current plus equals the deficit. Unallocated subtracts by the deficit. New stations, the right index is equal to the deficit. Current subtracts from stations on the left side. Current subtracts by the new station from the left side. Huh. Okay. What is the issue here? Okay, so this thing somehow was able to do 54. Bars 2. So 13, 12, so current should be 25. It's guessing 54. So 25. So no, so its current's 25, then it adds in the 8. So that should be 33. Deficit should be 54 minus 33 is 21. So it's like 2, something like that. Let's see what's going on here. So it's this one here. Why is it not printing more often? Should be printing. Oh no, okay, right side is initially 2 index. Okay. So it's 33 is the current window. Deficit is 21. So add 23 that's unallocated. So there should be 2 left that's unallocated. Okay. And then the next window should be 54 plus 14. So the next window should be 68. Okay. And then the next window should be, so 68. This is the center. So it shouldn't remove anything. So then the next window should be adding 7 to 68, so it'd be 75. Okay. And then the next thing should be that it subtracts 75. Yeah, okay. Yeah, okay. I'm doing the wrong right side index because right side index is actually as far as the range of window, the right side of a center, but the center is not reaching the very end. So I think this should be R from the R is going to be all the way to N plus R. Yeah, that's pretty bad. That's a pretty bad logic mistake. Yeah, disappointing. Okay, cool beans. I was actually suspecting that this would be better than this, but how can I make this better? I think what is possibly slowing down is the allocation of this array each time. If I didn't have that, then what would I use instead? Guess I would use a deck, to be honest. Double end Q. Just push onto the deck, pop off the deck each time. As long as it's in the correct window, then it should be fine. But I'm not sure. I mean, I guess I could reuse the same array and set it to be 0 at the start. Let me go ahead and try. Let me go ahead and try to reuse an array. New stations equals 0 times n plus r here, and I'll initially set the deficit to be 0. And then I will always set new stations at the right index equal to the deficit. Guess that might be fine. Not fine, not fine, not fine. Yeah, not fine. Yeah. Probably because the left side deficit is wrong. At the very end, it never resets it. Yeah. So again, I could use a deck. How much faster is a deck? Alright, fine. New state, say new deck is going to be double in Q, and then it should be something like new deck pushes the deficit onto it. Yeah, I guess it's append the deficit. And then when I remove on the left side is subtracting new deck dot pop left. This is right. You should be capital L. No, it's not right. Not right at all. Yeah. Yeah, it's just not right. The sizing is incorrect. Deck needs to be the size of the 2R. So, like, new deck needs to be like 0 times 2R or something like that. 2R minus 1. 0 times 2R minus 1. Close to that. Is it 2R? I guess if r is 0, then it can't be -1. Doesn't make sense. Then what does make sense? What the hell does make sense? No, this is just convoluted. I should go back to new stations. So convoluted. Do. Maybe it's the new stations that's the issue. No, I guess new stations is stuck. What am I doing? We have something on the left side, pop on the right side. For every index in range R, current stations. I wonder. If I go back to that one, new stations is the fixed array declared down here. I think maybe I can do something like new stations at -r-1 equals 0. Maybe. Oh, so close. I just need to clear off new stations. It just needs to be reset to 0. It doesn't get reset to 0 correctly. Does the other ones reset to 0 correctly? Nothing resets to 0 correctly. New stations. Yeah. Yeah. The main issue is the backside is incorrectly not resetting. So R here was 2, or was it 1? R here is 2. R here is 2. With R is 0, new station is 0. Oh, that's really weird. Index is, oh my god, I'm so stupid. I'm so stupid. Okay. I need to get rid of the print as well. Oh, did I already get rid of this? I saw one more print in here. Okay, so this thing goes back to a fixed array that's reused for the new stations. Oh my god, it got worse. Oh, good. Alright. I think this is probably just it. Yeah. Actually, now that I think about it, a lot of the calculation is already done. So at a certain, yeah, I'm redoing a lot of calculations now that I think about it, because the default amount of power at every position is already known. So I don't really need to do like a lot of this. I don't need to do this stuff right here. If I just use the default value. Okay. So I need to have like a baseline power for every station. Okay, so let's say baseline is equal to 0 times the number of stations, n. And then for every index, yeah, so let's say total is equal to 0 for index in range of r. Total plus equals the, actually I guess baseline could just be empty, an empty array that I append. Total plus equals the power at the station, so stations at index. And then for index in range r to n plus r, total plus equals stations at this index, baseline appends the total, and then total subtracts stations at index minus 2r. I think that's correct. And then I just use the baseline rather than recalculate it each time. So current is equal to, so I don't think I need, I guess I need this part, to be honest. I'll just comment that out. So current is equal to 0. I guess I just use, instead of, no, I still need current. Yeah, I still need, do I need current? What do I do if I don't have current? So I guess maybe it should be added. Yeah, added power at some index. So it should just be something like the deficit is 0 if the current, which should be stations baseline at index plus whatever added power there is less than the power level wanted. The deficit is going to be power level minus baseline index plus the added. If the deficit is bigger than n, okay, return false. Otherwise what? Otherwise, added is increased by the deficit. Unallocated is subtracted by I guess, yeah, it's fine. Unallocated is subtracted by the deficit. New stations at the right index is gonna be new stations at the right index is gonna be equal to the deficit. Baseline index plus added. Then I need to subtract the added, right? And remove the added. So this thing is not necessary. Added, subtracted by new stations at right minus 2r. Added power. Add power based on deficit. Yeah. Guess that's correct. Huh. There's a lot of changes. Probably made some mistakes. Baseline at index, I think should be right. Index out of range. Oh boy. Oh boy, line 16. Baseline at right. Fudge and put it. Right. I think this should be right minus R is where the center is. Oh fuck. That's probably not the only mistake I made for that thing. This is getting too complicated. I'll try to speed up a very minimal amount of stuff. Yeah. Okay. I am done. Yeah, that's as far as I'm gonna try to go for optimizing this. Kinda am interested to see what the actual better strategy would be. That being the case, I still think this is actually pretty reasonable, even if it's considerably worse than the other ones. There's probably maybe, is this the difference between sorting it and is my solution like an order of or is the actual optimal solution O of n? That would be kind of sad if it was, because then this is really going to be unoptimal. O of n. O of n solution. O of n solution. Yeah, okay. I'm gonna wave the right flag here. Summary. So a few techniques here. So binary search to use binary search as an overall strategy to find the max possible min power. Requires to have a linear is possible function that returns true if a given power level is feasible by any allocation, by any kind of optimal allocation of the, what is this called, of stations in that is possible function. Basically try to basically determine the deficit for any city index to the power level and simulate adding the needed power stations at index plus r, kind of max farthest away position that still provides power coverage to this index. Return immediately false if at any time the deficit is greater than the remaining unallocated stations. In the main code, initialize a low and high guess power level, use a while loop to iterate to kind of to guess the middle level, which then adjusts either the high or low depending on if the middle is possible. So if you have a low power level, that's possible. Or if you have a middle, that's possible. That means that the low, then you should treat that as kind of a new low and guess something higher. So if it's possible, the return value is going to be true. So low is going to be adjusted upwards. If it's not possible, then that means your guess was too high. So that means you need to adjust your high bound to be lower. And then lastly, return 1 less than the impossible value at the end. So this thing is going to stop when basically it's at the boundary between good and bad. It's at the false boundary, which is on the higher side. So then return 1 less of it to be the highest true value. Anyways, time complexity is going to be O of n log n, where n is the number of stations. as the binary search. We'll go through kind of all possible power levels. Is this n log n? Actually, maybe it's n log k. It does a binary. The function itself is O of n. I think it's n log k. Is k reused here? K. What is the upper bound of the number of things? The upper bound of the number of things is, say, n log x. Okay. Where n is the number of power stations and x is the maximum power level, which in theory is the sum of array plus k. So yeah, which is going to be log of that x, and each search takes O of n time. Yeah. Space complexity, this can be O of r, to be honest. No, O of n plus r, to have some dummy data structure to keep track of the new stations being allocated. Could be optimized to use O of r, I think.